Hello, good day viewers. In this tutorial, we are going to solve first question on the principle of electrical engineering 2. So, our first question says that a toroid is composed of three ferromagnetic materials and supplied with a coil having 100 turns. So, we're having the number of turns at 100 turns. And then the material are made of iron having a length of L1. We're having L1, which is 0.3 meter, and also we're having L2, which is 0.2 meter, and then also we are having L3, 0.1 meter. So the cross-sectional area is 0.01 meter square. So the area is 0.01 meter squared. And then if H1, the magnetic field, is 1085 meter, and the second magnetic field is 6685 meter, and H3 is, we're having 32485 meter. So the question says calculate the magnetomotive force to establish a magnetic flux of what? If the flux is 0.006, we are having 0.006 wave. So what we are to find the magnetomotive force. So how can we find the total magnetomotive force? We all know that the magnetomotive force, the MMF is equal to number of turns multiplied by the current. But the question says we are to find the total magnetomotive force. We can say the total magnetomotive force, MF, it is equal to what? H1L1 plus what? H2L2 plus H3L3. So we're having our H1, the magnetic field, which is 10 multiplied by the length. We have a length 1, which is 0.3, and then plus H2. We're having 66 multiplied by what? By L2, which is 0.2 plus H3. We're having H3, 324 multiplied by what? By L3. So we're having 0.1. So indeed, our final solution, if we say 10 multiplied by 0.3, we're having 3 plus 66 multiplied by 0.2, we're having 13.2, and 324 multiplied by 0.1, 324 multiplied by 0.1, we have plus. So if we add 3 plus 3.2 plus 32.4, we'll end up having 38.6 what? Ampere turn. So here we made a mistake in multiplying 324 multiplied by 0. Before we put 23.4, but the actual value is 324 multiplied by 0.1. It will give us 32.4 plus 13.2 plus 3. It will give us 48. The actual number is 48. So let's have 48. So here is the solution of the first question. The second question says we are to find the current. So how can we find the current? We all know that We all know this relation. Magnetomotive force is equal to number of turns multiplied by what? By the current. So we are looking for the current. So here is the first question. Here is the second question. So how can we find the current? We'll just divide both sides by what? By the number of turns. Divide both sides by the number of turns. Number of turns will cancel number of turns, and we're having the current, which is equal to magnetomotive force over what? The number of what? Of turns, which will be equal to our total magnetomotive force is what? 48.6 over what? Over the number of turns. Yes, number of turns is given, which is 100 tons. So therefore, the final answer, the current should be equals to, if we divide 48.6 with 8.6 divided by 100, so we'll have 0.486 what? Current. So that's what we have. So therefore, the next question says that determine or calculate the reluctance and permeability of each material. We are to find what? We are to find the reluctance S of what? Of each material, and what? And the permeability of what? Of each material. So how can we that? How can we calculate these two? We are to find the reluctance of each, of L1 for L1 for L2, and also for what? For L3, and also the permeability for what? H1, H2, and what? And H3. We all know the relation which says flux, it is equals to magnetic field multiplied by what? By area. So magnetic flux is given, and also area is given, but the magnetic field is not given. So we have to make it the subject and find the magnetic field. So it will be divided both sides by what? By A, and A will cancel A. So therefore the magnetic field will be flux over A. So our value of flux is 0.0006 divided by our area, 0.01. So the total magnetic flux is 0.06. 0.06. And then the question says we are to find the reluctance and what? And permeability of each material. So we all know that there is a relation that the magnetic field, it is equal to what? Mu multiplied by what? Mu multiplied by H. But what? We are looking for what? Permeability of H1, H2, and what? H3. It means the permeability of what? Of each material. So we have to divide both sides by what? If we divide both sides by what? By H will cancel H. We'll have mu 1, it is equals to what? Magnetic flux over what? Over H1. So therefore mu 1 will be equal to the magnetic what? Magnetic field, which is equal to 0.0 over what? Over H1 over 1080. Forget about the units. So therefore this here is the permeability of what? Of one material. So therefore the second material, the permeability of what? Second material is 0.06 over what? H2. We are having 66. And therefore the mu 3, the permeability of the third material is what? We're having 0.06 over what? Over 324. So let's calculate 0.06 divided by 10. We have 6 times 10 exponential of negative 3. 0.06 divided by 66. So we're having 9.09 times 10 exponential of negative 4. It's 4. And then 0.06 divided by 324. 1.85 times 10 exponential of -4. So the second statement has been solved, which says that determine or calculate the permeability of each word of each material. So the next thing is to find what? To find the reluctance of each material. So whenever you are solving this kind of problem, you have to be aware with units. Henry per meter, Henry per meter, Henry per meter for the what? For the permeability. So the third question says we are to find the permeability of each material. And then here is the permeability of each material. We're having 3 materials. So therefore, the next thing is to find the reluctance again of each material. So the general formula for the reluctance, let's say we can use this relation over mu multiplied by E. So we have to say the reluctance 1, the first reluctance, we're having L. So we are using which L? We are using the first length, which is 0.3 over, we are solving the first reluctance, so therefore we have to use the first what? The first mu, which is 0, which is the same thing as 0.00006. So we can just put it as 6 times 10 exponential of -3 multiplied by the area, which is 0.01. So, and therefore the second reluctance, we're having the second length, which is 0.2 over our second mu, which is 9.09 times 10 exponential of what? Exponential of -4 multiplied by 0.01. And then the third reluctance, our length is 0.1 over the mu, we're having mu, the side mu, which is 1.85 times 10 exponential of -4 multiplied by the area 0.01. So if you calculate, it will give you the reluctance of what? Of each material. So let's calculate and see. 0.3 over 6 times 10 exponential of -3 multiplied by 0.01. We're having 5,000. Well, let me put it here. We're having 5,000. So what of the unit? We're having what? Ampere per Weber. So let's insert the second value. We're having 0.2. Let's say 0.2 over 9.09 times 10 exponential of -4 multiplied by 0.01. So we're having what? 22002 what? Ampere per watt. Here we're having S2, we're having S1. Here is 5,000 per wave. And therefore, 0.1 over 1 times 85 times 10 exponential of -4 multiplied by 0.01. We're having what? S3 is equals to 54054 ampere per wave. So here is the full solution of the first question. So let's move to the second question. The second question says that a magnetic field is having a mean co-length of 0.1 meter. Let's see the second question. Having a length of 0.1 meter. Area of the cross section. The area of the cross section, which will be 1.5 meters square. 1.5 meters square. And what? And a coil of 200 turns carrying a current of 20 amp. So the number of turns, which is 200 turns. 200 turns. And then the current is 20 amp. The current, which is 20 amp. And then also carrying a current of 20 amp wound on it. If the flux density is what? Is 4 Tesla. The flux density is what? 4 Tesla. So find the Magnetomotive force. We are to find Magnetomotive force and find what? Magnetomotive force, magnetic flux. We are to find the flux, the magnetic flux, and also we are to find the reluctance S, and also we are to find the permeability, and magnetic field intensity of what? Of the circuit. The what? Magnetic field intensity of what? Of the whole circuit. So this is the data that we have. We are having the length, the area, the number of turns, and also the current. Let's say the current to be I, and also the flux. So how can we solve the Magnetomotive force? We all know that the Magnetomotive force, it is equals to number of turns multiplied by what? Multiplied by the current. So here is straightforward. We are having the number of turns. So our number of turns, which is N, we are having 200 multiplied by what? Multiplied by what? The current. And our current is what? Is 20 amp. So therefore the Magnetomotive force is 200 multiplied by 20. We're having what? For what? We're having 4,000. So the next question, we are to find what? We are to find the flux. So therefore we are to substitute the value of magnetic field. So therefore flux is equals to, we have our magnetic field. No, we're not having magnetic field. So we have to say, okay, sorry, our magnetic field, which is what? Sorry, I have to put the V here. We're having what? 4 multiplied by what? By the area. So our area is 1.5 meters square. So if we say 4 multiplied by 1.5, so we're having 6. So therefore we're having 6 what? 6 Weber. So therefore the next is to calculate the what? The reluctance. We all know that the general formula for the reluctance is what? S is equals to L over what? Mu R, and what? The relative permeability, and what? The mu naught multiplied by what? By the area. We can use this relation as what? As our reluctance. But we can also use another relation. We can say that the value of the reluctance will be Magnetomotive force over what? Over the flux. So therefore we are having flux. So therefore the Magnetomotive force, which is what? Our final Magnetomotive force is what? Is 4,000 over what? Over the flux. Our flux is what? Is over 6. So therefore the reluctance will be 4,000 divided by 6. So we're having 666.67. 666.67 per watt, A power wave. So therefore the next thing is to find what? The permeability. So we know the relation that say the B magnetic field is equals to mu multiplied by what? By the H. So we are looking for what? For the permeability. So divide both sides by H, divide both sides by H, and what? H will cancel H. So therefore the value of the permeability mu will be equals to what? Magnetomotive force over what? Over H. So therefore the value of here is what? We are having 4 Tesla over what? Over value of what? Did we have the value of H? We don't have the value of H, but we can relate it as what? MMF for what? per our length. Our length is 0.1. So we have to say, if we say mmf, the value of magnetomotive force, which is mmf, so we have to say the what? Our h is mmf over what? Over the L, which is, we are having 4,000 over 0.1. So therefore the value of h will be 4,000 divided by 0.1. So therefore we are having what? 40,000. We're having 40,000. So we have to say 4 over the 40,000. So if we divide 4 divided by 40,000, so we have 1 times 10 exponential. So therefore the mu will be equals to 1 times 10 exponential of what? Exponential of -4 h per what? 5 meter. So as you can see, the value of what? Magnetomotive force, here is the final answer, and you can use this relation, you can use the formula, and therefore if you are going to find the flux, you can also use the relation, and also here is the final answer. For the reluctance, we have 2 formula here, but according to the, if we are going to prove, we can have another formula, but we are going to use the 2 formulas. If you are going to use this formula, you must have what? The relative permeability, and also you must have what? The mu naught. So here is another mention problem, question 4. The question says that a single phase transformer has a 300 turns and 120 turns in each secondary and primary. Therefore the number of secondary is what? Is 300, and therefore the number of primary, it is 120 what? Tons. And what? Of secondary and primary windings respectively, it has a primary resistance. Let the primary resistance be Rp, which will be equals to 0.67, and therefore the secondary resistance, which is Rs, to be 0.23 ohm. Calculate the first equivalent resistance of what? Of the primary refers to what? Refers to secondary. So how can we find the equivalent resistance of what? Of primary refers to secondary? So I think here is one equation that we can use. The Rp prime, it is equals to the R square multiplied by what? By Rp. So what is R square? R square, we all know that we have to first find the what? The turn ratio. The turn ratio R can be equals to the general formula E2 over what? Over E1, and also we know that our E2, which is what? Secondary over what? Over primary. We have to say what? Sorry, primary 120 over what? Over 300. E2 over E1. The NS secondary is what? E1, and what? The primary is what? Is E2. So therefore 120 over what? 120 over 300, 0 will go 0. Yeah, we are having 0.4 ratio. So therefore we have to say the Rp prime, it is equals to what? 0.4 square, if we use this relation. So therefore multiply by what? Rp. The value of Rp, it is what? 0.67. So if we say 0.4 square, we are having 0.16 multiplied by 0.67 multiplied by 0.67. We're having what? We're having 0.10 0.1072. So therefore the first question that we are asked to find the equivalent resistance of what? Of the primary refers to what? Refers to secondary. So the second said that we are to find what? Secondary resistance refers to what? Refers to primary. So I think we can use the relation of Rs prime, which will be equals to what? Will be equals to Rs over what? over R square. So the value of RS we're having 0.23 over what? 0.4 square is 0.16, and therefore 0.23 over 0.16 over 0.16, we are having 1.4375 what? 75 ohm. So therefore we find the equivalent resistance of primary refers to what? Okay, sorry, of primary refers to secondary. That's why we have primary RP prime, because we first call what? The first we are looking for the primary, and then the secondary refers to what? Refers to primary. So therefore we're having what? RS. So therefore the third problem said that we are to find the total resistance refers to what? Refers to primary. Total resistance refers to what? Refers to primary. So therefore the total resistance, let's say here I3, total resistance refers to what? Let's say RT primary. Total resistance refers to what? Primary. So what relation can we use? We can use the relation RP plus what? RS what? RS prime. We're having RP. RP is 0.67 multiplied by what? RS prime. The total RS prime we're having 1.43 what? 1.4375. So therefore, the total resistance refers to primary is, if we say 0.67 plus 1.475, we'll have 2.1075. So we're having 2.1075 ohm. So therefore here is a fourth question that it is inside the past question of what? Principle of electrical engineering 2.